Mrs. Riley's Maths videos. Today we're looking at rectangular solids, and we're looking at the volume and surface area of those. So the first thing I would say to you is to get a cereal box, and I'm sure you have plenty of cereal boxes at home. Get a cereal box and have it ready for the rest of the video. Okay, so if you just want to go and get that now, pause the video and then come back to me. Okay, so there's a variety of rectangular solids that you have around your house. You've been learning about them since you were in national school, so this shouldn't be too difficult for you. Let's start with volume first of all, and volume of a rectangular solid. So let's just draw a quick sketch of what a rectangular solid might look like. So here is a rectangular solid. It's a rectangle, but it's obviously got a three-dimensional quality. So there we are, there's a rectangular solid. The volume of a rectangular solid, as I hope you know at this stage, is going to be length by width by height. Okay, so volume equals length by width by height. It really shouldn't be a problem for you. Okay, so any three measurements on the rectangular solid, multiplying them together to get the volume. So for instance, if I had a rectangular solid here, which was like so say this was 20, this was 6, and this was 10, the volume of this box of this solid would be length, which is 20, by 6, which is width by height, which is 10. Length by width by height, which is 1200, whatever. So let's better give them some units, centimeters. So 1200 centimeters cubed. So remember, for volume or capacity, you're talking about centimeters cubed. Okay, centimeters cubed. Okay, so that's the volume. What you might be told, I suppose, is you might be given a rectangular solid. If I try to draw them differently now, I know I'm going to get into a mess, so shouldn't really bother. Anyway, there's a vaguely rectangular solid. And say we were told that this was 30, this length was 30 centimeters. Say we're told the width was 4 centimeters. And we're not told what the height is. The height is x centimeters. And say we were told that the total volume of this box is 600 centimeters cubed, and we're asked to find the height of the box. Okay, so that might be a problem we're presented with. We're given 2 dimensions out of the 3. We're told the volume and we're asked to find the height. So the volume is equal to length by width by height, which equals 30 by 4 by x, and we know that that equals 600. So we know that 120 times x equals 600. So x must be whatever it takes to multiply by 120 to get 600, and that would be 5. So x is 5 centimeters. Okay, so that's straightforward, I hope. Length by width by height for volume of a box. And just remember, volume is the same as capacity. So really the volume of a box or the volume of a container is how much it can hold. What's its capacity? Okay, so hopefully you have your cereal box now, and you can open out your cereal box. So you have your cereal box, I hope. Coincidentally, I have this miniature cereal box, which I just rescued from the recycling. So we're just going to talk about the surface area and the net one more time before you try those questions over the next couple of days. So what I'm going to do is I'm going to cut this open. The thing I want to avoid is having any overlap sides. So what I'm going to do is I'm going to cut along here. So if you could be cutting up your cereal box at the same time. So I'm going to cut along here and along here, and I guess along here. I want it all to stay in one piece, that's kind of important. And I guess I better cut along here then. So we're nearly there. I just need to cut along here, and then I'll open it out. So now what I'm going to do is I'm just going to trim off any bits that are overlaps. So that's not quite an overlap. Here I think is an overlap. So if you notice here now, I have my cereal box. You should have your cereal box spread out. There it is. If I was to refold it, I would have a complete box. So there's the complete box. Okay, and here it is opened out. Okay, so working out the surface area. If you remember, we talked about the surface area as being the amount of paper you need to cover a shape. So in this situation, you can see, possibly more clearly on this side, we have, let's draw this line here to emphasize it here, because it's kind of not so clear on the video. This is a seam here. This is one of the edges. We've got this side, we've got this end bit. So we've got the Kellogg's Cornflakes, we've got the end panel, we've got the back with the puzzle thing, we have the panel that has all the allergens and everything in it, and then we have the top section here and the bottom section here. Okay, so the front, the back, the two side panels, the top and the base. Okay, so we have the front, the back, and those two are identical. Side panel, top and base. Okay, so if I was to draw the net of that, what I would need to know is I'd need to know all the measurements here. So let's see, this is a protractor, so probably not great to measure with a protractor. Set square is going to be too small. Where's my ruler? Okay, so here is my ruler. So this is, let's say, 7 centimeters. So from there across to there is 7 centimeters. From here down to here, let's just say it's 10.5. Okay, we'll just round it off. 10.5. Down to the base here is 10.5, which means, of course, that this over here is 7 centimeters across here, and this is 7, and that up here is also 10.5. Okay, 10.5 down to the base. Now the way I've cut it, it's slightly less than 10.5, but that doesn't matter. So we've got that measurement. We haven't got this measurement, which is 4. So we put that in there. That's 4 centimeters. This, of course, is also 10.5 because it's the same height as the others. 10.5. So hopefully you're doing yours. 10.5, 10.5. This will be 10.5. We know now. 10.5 down to the bottom. Okay, and this here will be 4. This here is 4 centimeters. So that's all those bits done. Now the top and the base, I'm going to use the base because it's slightly neater. So the base is 4 centimeters this way. So 4. And of course this is 7 because we had that the same as the back. So that's going to be 7. And then the top, the base, the top will be the same. So that'll be 7. I know it doesn't quite look like that, but it's just the way I've cut it. And this will be 4. Okay, so that's our measurement of all our different parts of our cardboard box, our miniature cornflakes box. Now that's your net. So if you were to draw a net, that is how you would draw it. You would draw your 1, 2, 3, 4 sides, 5, 6 sides of your rectangular shape. You would make sure you fill in the measurements on that shape, otherwise it doesn't make sense as a net. Now if you're going to scale, if you decided that 1 square was 1 centimeter, then obviously you'd need this number of squares. You'd need 4 squares, 7 squares, 4 squares, 7 squares, 10.5 squares for this part. But I'm not going to work out the net of this. I'll leave that for you to do. But you know now what the net looks like. The usefulness of the net and of this unfolding is it helps us to work out the area of the surface area of the solid. And this is true for any solid. So we can use this principle for any solid. This was made up of this shape, remember? If we were wondering how much paper or what's the surface area of this shape, the way that we would need to work that out is we'd need to cover this side, we'd need to cover this side, we'd need to cover here, and then we'd need to cover the base and the top. So that's what we have in here. We have all these different shapes. So we have this side here, okay? This side here, the area of that is going to be length by width, which is 4 by 10.5. It doesn't really matter what I call length and what I call width. So that's going to be 42 centimeters squared. This one is going to be, the area is 7 by 10.5. What's that? 73.5 centimeters squared. This is also going to be 42. Area equals 4 by 10.5, which equals 42 centimeters squared. And this is also going to be 7 by 10.5, which is 73.5 centimeters squared. So that's my 4 main ones. Then the base here is going to be area will be 7 by 4, which is 28, and area here will be 7 by 4, which is 28. Okay, so the total surface area of this shape, let's put it up here and we'll work it out. Okay, so the total surface area of our miniature cornflakes box, total surface area of cornflakes box is going to be, what do I have? I've got 2, a back and a front, which are both the same. So back plus front, which equals 2 times what they were 7 by 10.5. And then we'll do that in a minute. Well, actually, I suppose we'll do it now. 2 by 73.5, which is 147 centimeters squared. Then we've got the 2 side panels. Okay, so the 2 side panels, so side plus side, so we've got 2 of those, so it's 2 times 4 by 10.5, which is 2 times 42, which is 84 centimeters squared. And then we have the top and the base, top plus base, which is equal to 2 times 7 by 4. 2 times 7 by 4, which is 2 times 28, which is 56 centimeters squared. So adding all those up, our total surface area equals 147 plus 84 plus 56. 147 plus 84 plus 56. 147 plus 84 plus 56. Why is that not working? Oh, sorry about that. 147 plus 84 plus 56 equals 287. I should have just done it in my head. 287 centimeters squared. That's the total surface area of that rectangular box. Okay, hopefully that's useful and will help you as you work through the problems on area and volume of rectangular solids.